Hello everyone. Today we are going to start the new chapter, probability. What is probability? Well, you have taught for probability sixth grade in sixth grade, and you know some things about it. And this year we are going to increase our knowledges related to probability. You know that probability is the chance that an event have for happening. Some events are more likely to happen than others. In mathematics, the word probability is used to describe this situation. Okay, there is a high probability that you will put on shoes tomorrow. So if you go out, of course you will put on shoes. And there is a low probability that you will stay awake for 24 hours. Okay, some cases of probability. The probability of an event is given a number from 0 to 1. Okay, so you must know this one. The probability of an event is always a number between 0 and 1. 0 means that this probability is impossible. Okay, this event cannot happen. It is impossible. If the probability is near to 0, it means it is unlikely to happen. If it is 0.5, it is just as likely to happen or not. Okay, it is even chances to happen or not to happen. If it goes near to 1, this one is nearly to a certain event. And if it is 1, it is a certain event. Okay, it is 100% sure that this thing will happen. Now let's talk about experimental probability. What is experimental probability? Experimental probability is the probability that we get after we make a survey or an experiment. Okay, so we'll make an experiment, we'll register all the data that will come in this experiment, and after that we can take a probability for the things that we want to find. So the probability of an event occurs is a successful outcome. Okay, so the probability of a successful outcome is the number of successful outcomes over the total number of outcomes. Okay, the number of successful outcomes over the total number of outcomes. For example, if you throw a coin 100 times, so what is the total number of throws? It is 100. So the total number of outcomes will be 100. Now I want to get to find the probability of getting a head. Okay, so I throw it 100 times. I take note for each of the results that is coming in a table, and I saw that the number of getting head is 50. So the probability for getting head will be 50 over 100, which is 1 over 2 or 0.5. Okay, so many of probabilities can be found by experiment or survey, and some of them are found by theoretical probability. Let's see one example. 50 people were asked their favorite sport. The results are shown in the table. Okay, so I go out, I ask 50 people about their favorite sport, and I took note about the result. 17 of them liked cricket as the favorite sport, 8 of them basketball, 20 of them netball, and 5 of them football. So now I have to find the probability that the person's favorite sport is football. So as we said, to find the probability for football, I need the total number of people that I get surveyed or asked, which is given as 50. Okay, I know it is 50. And the number of people which like football, it is 5. So it will be 5 over 50 or 1 over 10 if you simplify. At B, let's find the probability that a person's favorite sport is not netball. Okay, not netball, it means it can be any other of these sports, but not netball. It means you have to take out the results for netball. So it will be what? 17 plus 8 plus 5 will be the possibilities that the sport is not netball over the total number of people, which is 50. So it is 30 over 50 or 3 over 5. Now let's continue to solve some exercises. Until exercise 5, it means the first 4 exercises are experiments that you have to do. If you want, if you wish, you can perform these experiments and find the probabilities. If you not, you will have to solve the exercises on iExcel, so it is not a problem. Now let's continue with exercise 5. Packets of flower seeds are checked for purity in case any wheat seeds have been included. Here is a frequency table showing the results of checking 100 packets. Okay, so the total number of packets that I have checked is 100. Okay, so the number of all outcomes will be 100. Now let's have a look on the frequency table. So there are 5 packets of flower seed which has 0 wheat seeds. There are 16 which has only 1 wheat seed, 26 which have 2 wheat seed, 19 which have 3, 13 which have 4, 12 packets have 5, 5 packets have 6, 2 packets have 7, and 2 packets have 8 wheat seed. Now we have to find the probability that a packet contains 6 wheat seeds. Okay, so probability of 6, sorry, one more time, probability for 6 wheat seeds. So number of wheat seeds, it is here. So at 6 I have 5 packets. Okay, so the number of packets which has 6 wheat seeds is 5, and in total I have 100 packets that I have checked. So the total number of outcomes will be 100. So 5 over 100 or 1 over 20 will be the probability for this one. B, 1 wheat seed. So probability for getting 1 wheat seed is what? So 1 wheat seed, 1 wheat seed. The number of packets which has 1 wheat seed is 16. So it will be 16 over the total is 100. Okay, if you simplify this one by 4, it will be 4 over 25. 4 over 25. More than 6 wheat seeds. More than 6, I mean 6 is not included, it is more than 6. So it can be 7 or 8. For 7 we have 2 packets, and for 8 we have 2. So the probability for more than 6 will be what? 2 plus 2 over 100. 2 plus 2 over 100, which is 4 over 100, or 1 over 25 if you simplify with 4. 1 over 25. Okay, so in this way, we get the probabilities. Now let's see exercise 6. A scientist weighs kitten at birth with the following results. Okay, so mass 190 gram. There are 13. 34 with 200 gram. 57 with 210. 50 with 220. 29 with 230. And 12 with 240. 5 with 250 grams. A, how many kittens did the scientist weigh? So to find the number of kittens that the scientists weighed, we have to add all the frequencies. Okay, we know this one, we have done before. So I have to add 13 plus 34 plus 57 plus 50 plus 29 plus 12 plus 5. So let's add them. Okay, so I have 60, 70, 70, 120, 120, 154 plus 12, plus 29, plus 12 plus 5, that will give me 200. Okay, so in total I have 200 kittens. Find the probability that the kitten has a mass of 250 grams. So 250 grams, there are 5 kittens with 250 grams. So the probability for 250 grams will be what? 5 over the total, which is 200, the total number. If you simplify with 5, it will be 1 over 40. 1 over 40. Less than 250, less than 250 means it cannot be 250, but it can be any of these ones, So it will be what? Less Okay, so what is the number that is less than 250, the number of them? So 200 are in total, minus 5, it will be 195 over 200. Over 200. This one can be simplified with 5. So it is 39 over 40. 39 over 40 will be the probability for getting less than 250 grams. Now let's have a look on exercise 8. These are the marks of 50 people who took a skill test. The maximum mark was 240. And the maximum mark is 240. What is the probability that the person chosen at random scored 120 to 149? So in total, I have 50 people, okay? So I know the total number of outcomes. 120 and 149, okay, is this one. In total, for this one, there are eight people. So the probability for it, 120 between 120 and 149 is the number of the persons who took this mark, which are 8, over the total number of people, which is 50. 8 over 50, or 1, can it be simplified with 2, 4 over 25. 4 over 25. B less than 30, I have to find the number of the people who get less than 30. It means the ones who had get between 0 and 29. So probability for getting less than 30, let me write like this. 30 is not included. When we say less than, it is not included. So it is 2 over 50. or 1 over 25. 1 over 25. Between 120 179, so 120 starts from here and 179. That means I have to take both these intervals. So the probability between 120 and 179 will be 8 plus 7 over 50. Okay, it is 15 over 50, or if you simplify with 5, 3 over 10. 3 over 10. 180 or over, 180 or over means it starts here and finished at the maximum one, which is 240. So I have to take these two now. So probability for 180 or over, it means continuous like this. It will be what? 2 plus 1 over 50. Okay, which is 3 over 50. This probability. So in this way, we can find the probabilities of experiments that we can perform. Okay, these ones are the questions for today. I wish you a nice weekend, and we'll continue on Monday with theoretical probability. So see you on Monday.